Imagine this. On a quiet day in 2026, we decide to leave everything behind. You step aboard the most advanced spacecraft ever built, fasten your seatbelt, and point the nose straight into the darkness. Leaving Earth, leaving the solar system with one single goal: to escape the Milky Way. A simple question begins to form in your mind. How long would it actually take to reach the outside? At first, it feels like an easy calculation. Distance divided by speed equals time. But in the universe, numbers don't behave the way we expect them to. And the deeper you go into the answer, the more you realize the problem is far larger than it seems. Recent data from NASA hints at something unsettling. The greatest obstacle isn't just the immense distance. It's where we truly are within this vast system and how it quietly holds us in place. What makes this journey feel almost impossible isn't simply how far we need to go, but the fact that we don't fully understand what we're trying to leave behind. There is an invisible boundary out there, and speed alone may not be enough to cross it. If you're someone who's drawn to questions that linger a little longer, questions that make you rethink your place in reality, consider subscribing to Space Lull, because tonight we won't just measure distance, we'll begin to understand the vast cage we call the Milky Way. To understand why escaping the Milky Way is a problem that feels almost unsolvable, we have to begin with something humanity has always been proud of: speed. Throughout history, we've been obsessed with breaking limits. From transcontinental trains to supersonic jets to the massive rockets of the Apollo program. We've always taken pride in numbers, in the idea that with enough power, enough engineering, we can conquer space itself. But the moment we place those numbers against the scale of the universe, that pride quietly transforms into something else, something far more humbling. Take Voyager 1, the most distant human-made object ever sent into space. Right now, it's traveling through interstellar space at about 11 miles per second, 17 kilometers per second. To put that into perspective, that's roughly 50 times faster than a rifle bullet. At that speed, you could cross the entire United States from New York to Los Angeles in under 4 minutes. An astonishing number, isn't it? And yet, even that isn't our limit. There is also Parker's Solar Probe, a technological marvel designed to touch the sun itself. By harnessing the immense gravity of our star, it has reached record-breaking speeds of about 118 miles per second, 190 kilometers per second. At that velocity, a flight from Washington, D.C. to London would take less than 30 seconds. This is the pinnacle of modern propulsion, proof of what human intelligence has achieved in the 21st century. Within the solar system, these spacecraft are gods of speed. They turn distances of billions of miles into journeys measured in decades. But pause for a moment. Now, pull the camera back, beyond the planets, beyond the edges of the solar system, and look at the full structure of the Milky Way. And suddenly, a shift happens. In a galaxy containing hundreds of billions of stars, a speed of 118 miles per second becomes almost meaningless. It's like an ant trying to crawl across the entire continent of North America. Even if that ant were the fastest of its kind, on that scale, its movement would be nearly indistinguishable from stillness. The universe does not measure in miles. It measures in the silence of time. If we were to attempt escaping the Milky Way using the fastest speed humanity has ever achieved, the very concept of time would begin to dissolve. Years would become centuries. Centuries would become millennia, and millennia would feel like a passing moment in the span of such a journey. This contrast reveals a harsh truth. What we call fast only has meaning within the small pond we live in. Step into the cosmic ocean, and even our fastest spacecraft becomes little more than driftwood. We begin to realize something unsettling. It's not that we lack willpower. It's not that we lack courage. It's that we are confronting a system so vast, it challenges the very logic of mathematics and existence itself. Imagine this. You're sitting inside a spacecraft, moving at a speed that feels unimaginable. Yet when you look at a galactic map, the tiny point marking your position barely moves, even after thousands of years. That feeling is not just waiting. It's something deeper, something closer to existential helplessness. We've always believed that if we could just go faster, we would eventually arrive. But the truth is, the universe is so vast, it has the power to absorb all speed. Distance is no longer just a stretch of space. It becomes a chasm, separating human reality from the eternity of the stars. And if 118 miles per second, the pride of our technology in 2026, is still considered motionless within the Milky Way, then a far more unsettling question begins to emerge. If this is the fastest we can imagine, what exactly are we facing out there? And is it possible that we are living inside a system that humanity was never meant to leave in the first place? We've already seen how even our fastest spacecraft begin to feel slow. But the real reason they appear almost motionless isn't just about engines. It's about the very nature of the space we are trying to cross. To measure the universe, scientists had to abandon every familiar human unit. Miles and kilometers become meaningless here, like trying to measure the distance from Earth to the Moon with a strand of hair. Instead, we use something else, a light year. By definition, a light year is the distance light travels in a vacuum over 1 year, about 5.88 trillion miles, or 9.46 trillion kilometers. Pause for a moment and let your mind try to process the word trillion. A million seconds is about 12 days. A billion seconds is 31 years. But a trillion seconds? That's over 31,000 years. And that is just the scale of a single light year. The problem is, the human brain was never built for this. We evolved to gather on open plains, to hunt through forests, to move between cities. Our intuition is designed for distances we can see or walk. We understand 10 miles, 100 miles, even 3,000 miles across the United States. But the moment we step into the realm of light years, our intuition collapses. We can say the numbers, but we cannot truly feel them. Take our closest neighbor, the Proxima Centauri system. It lies about 4.2 light years away. Now imagine this. Shrink the sun down to the size of a grain of sand. The Earth becomes a speck of dust about 1 inch away. At that same scale, the nearest star, Proxima Centauri, would be 4 miles away. And between you, the dust, and that distant grain of sand, there is nothing. No bridges, no landmarks, just darkness. Cold, empty, infinite space. And that is just your neighbor. To leave the Milky Way, we are not talking about 4 light years. We are talking about tens of thousands, even hundreds of thousands of light years. This is where logic begins to betray you. When you hear that the Milky Way is about 100,000 light years across, your mind instinctively tries to linearize it. You think, if 4 light years is far, then 100,000 is just more of the same. But it isn't. Because at this scale, reality itself begins to change. Beyond a few thousand light years, the idea of a journey fades away and is replaced by something closer to eternity. Think about the images you've seen of the Milky Way, those glowing spiral arms, those shimmering clouds of dust. From the outside, it looks contained, finite, almost like an island in space. But that's an illusion. When you are inside it, every millimeter of that image represents billions of miles of emptiness. And here is the real twist. Once you pass a few thousand light years, space is no longer something you travel through. It becomes something that begins to consume you. On a transatlantic flight, you always know, no matter how vast the ocean, you are moving toward another continent. But in a journey out of the galaxy, after traveling 1,000 light years, you look back, and you are still essentially where you started. You look ahead, and the destination feels just as distant as it did in the beginning. Our intuition breaks because we expect milestones. But in interstellar space, there are no milestones, only the endless repetition of emptiness. Astronomers speak of these numbers as casually as grocery bills. But to a human mind trying to escape, 2,000 or 3,000 light-years is not just a distance. It is a psychological wall. It is the scale at which light from civilizations long gone is only just now reaching your eyes. You are not just traveling through space, you are traveling through the graveyard of time. So when we talk about leaving the Milky Way in 2026, we are confronting a deeper truth. We are short-lived beings trying to measure something eternal. Even imagining a distance of 100,000 light-years is enough to exhaust the greatest minds. So when you ask, how long would it take? Remember this. Our unit of years is far too small. We are not facing a long road. We are facing a dimension where every human definition of distance breaks down. And if just a few thousand light-years already exceed the limits of our understanding, then how can we possibly hope to reach the edge of this vast cosmic spiral? Is it possible that the universe has placed these distances deliberately as a kind of natural filter, ensuring that no civilization can leave its home unless it first finds a way to overcome space and time itself? Now, let's do what every logical mind wants to do. Let's connect the facts. We have the speed of the Parker Solar Probe, the fastest object humanity has ever built. And we have the scale of the Milky Way. Place those two side by side, and for the first time, numbers begin to emerge. But there's something you should be prepared for. These numbers will not feel like a journey. They will feel like eternity. We use the word travel, a word that implies a beginning, a path, and an end within reach. But when you apply a speed of 118 miles per second to the distance required to escape a galaxy, the idea of travel disappears completely. It is replaced by something far more unsettling in science: deep time. Let's try a rough mental calculation. To escape the galactic disk from our current position, assuming we take the shortest path, moving upward out of the plane rather than across its full diameter, we would still need to cross thousands of light years. At the limits of 2026 technology, the result is no longer tens or hundreds of years. It begins to climb into the millions. But let's pause before locking in a precise number, because that number is almost meaningless to the human experience. If I told you the journey would take 500 million years, your mind would immediately place it into the category of impossible and stop processing it altogether. So instead, let's look at what happens back on Earth while your spacecraft has barely begun its journey. Imagine this. Your ship leaves in 2026. You watch Earth slowly fade into the distance. 1 million years pass. Your ship has barely made progress on a galactic scale. But back home, humanity as you knew it may already be gone, or evolved into something unrecognizable. Continents begin to shift. Mountains you once stood on erode into flat plains. 5 million years pass. 10 million years pass. Your spacecraft continues forward, silently, endlessly, through the dark. At this point, we are no longer talking about a space mission. We are talking about an artificial object that outlives everything we would call a civilization. This first estimate reveals a brutal truth. A spacecraft attempting to escape the Milky Way would become a living fossil, a relic of a civilization that vanished long before it ever reached the edge. And this is where we encounter something deeper: the trap of persistence. We tend to believe that with enough time and enough endurance, we will eventually arrive. But the universe has a way of punishing that belief. At these timescales, even the stars themselves begin to change. Brilliant blue stars explode into supernovae. Sun-like stars age and fade. You are not traveling through a static picture. You are moving through a universe that is aging alongside you. When scientists at NASA and European Space Agency examine these estimates, they don't just see a limitation of technology. They see something else, a boundary between biological existence and cosmic reality. We are creatures of days and nights, of seasons, of lifetimes. Even a few thousand years already stretches the limits of what we can comprehend. Now consider this. Even if we increased our speed tenfold, the result barely changes. The timescale would still fall within the realm of geological ages. We are trying to measure a divine journey with the ruler of a human life. And this first estimate, though not yet the most extreme, already delivers a clear message. Escaping the Milky Way is not just an engineering problem, it is an existential cost. Can you begin to feel the weight of that number? When time is no longer an ally, but a vast abyss that drains all meaning from the journey itself. And yet, hold on to that feeling, because once we factor in gravity and the hidden structure, the dark regions of the galaxy, the true number becomes far greater. If time is the price we must pay for freedom from the Milky Way, would anyone truly be willing to pay a cost that neither they nor their entire species would ever live long enough to witness? By now, your mind may already be resisting the estimates we explored earlier. That resistance is natural. It's a built-in defense mechanism. Human beings were never designed to comprehend timescales that stretch beyond a few generations. But if we truly want to understand what it means to leave the Milky Way, we must allow the idea of human time to completely collapse. Let's begin with something familiar. All of modern human civilization, from the first pyramids, through the Renaissance, the Industrial Revolution, to this very moment, as you sit here watching, has unfolded over roughly 10,000 years. 10,000 years. A span we consider vast. A timeline that contains every war, every love story, every invention we've ever known. Now, place those 10,000 years onto a spacecraft moving at 118 miles per second, trying to escape the galaxy. After 10,000 years, your ship would have traveled only a negligible fraction of the journey. It wouldn't even have left the local neighborhood of nearby stars. Now let's go further. Step back into a deeper past, to the age of giants. Dinosaurs ruled Earth for about 165 million years, an incomprehensibly long era, long enough for continents to shift, for oceans to form, for entire ecosystems to rise and fall. And yet, if your spacecraft had launched at the very beginning of that age, today, after the rise of humanity, after all of civilization, your ship might only now be approaching the faint edges of the galactic disk. This is where something breaks, a true collapse in perception, because the time required for this journey is no longer connected to human existence. It belongs instead to geological time, and ultimately to cosmic time. When you step aboard that spacecraft in 2026, you are not joining a human mission. You are entering a process in which humanity itself becomes a brief flicker. As your ship moves forward through the dark, mountain ranges like the Rockies or the Appalachians will erode into flat plains. Great canyons will fill in and disappear. Earth's ecosystems will transform completely. New species will emerge and vanish. We often call ourselves the masters of Earth, but in this journey, Earth becomes nothing more than a shifting grain of dust fading behind you. And here is the most brutal realization of all. The entire history of humanity, from the first footsteps on grasslands to the most advanced supercomputers, is nothing more than a brief prologue to this journey. Everything we've ever done, everything we've ever known, everything we've ever hoped for, would barely fill the first few kilometers of a road that stretches across billions of miles. A spacecraft escaping the galaxy does not carry a delegation of humanity. It carries a fragment of memory, a moving artifact from a forgotten age of a distant planet. And as you sit in the cockpit, watching the mission clock tick forward, a quiet realization begins to settle in. You no longer belong to Earth's timeline. You have entered the timeline of galaxies, where time is not measured in years, but in the birth and death of stars. So why are we so obsessed with leaving? Why do we feel this pull toward the outside when the price is the complete erasure of where we came from? Perhaps because somewhere deep within us, there is a desire to transcend our limits, to witness the end of a story we haven't even finished reading. But remember this: time is only part of the trap. Even if you had all the time in the universe, the Milky Way still holds another force. Not distance, not time, but something invisible, something powerful enough to hold you in place. If the entire existence of our species is just the opening note of an endless symphony, would we have the patience to hear it to the end? Or would we fade away before the music truly begins? Up to this point, we've been talking about the Milky Way as if it were a vast desert, a place where, if you simply keep moving long enough, you'll eventually reach the edge. We imagine it as a flat map, a distance to be crossed. But that is the greatest flaw in human intuition, because the Milky Way is not a distance, it is a system. Imagine trying to escape a city. If that city were just a network of roads, all you'd need is a full tank of gas. But if that city were a prison, with invisible walls, magnetic barriers, swirling currents, and forces pulling you back from every direction, then your fuel would mean nothing. The Milky Way is that kind of prison. Our mistake has always been assuming that space is empty. In reality, the galaxy is filled with mass, and in the universe, mass means power. Every star, every cloud of dust, and especially the supermassive black hole at the center, Sagittarius A star, all contribute to a vast, invisible web of gravity. So when you launch your spacecraft in 2026, you are not entering a region of freedom. You are swimming upstream in an invisible ocean that is constantly pulling you back. Every mile you travel, the galaxy whispers, "You belong to me." Galactic gravity is not like Earth's gravity, something you can escape in a matter of minutes with enough thrust. It is persistent, relentless. Even when you are so far away that the sun is no longer visible, the combined mass of billions of stars behind you continues to tug at your ship, slowing you down, second by second, minute by minute, across millions of years. But that's only part of the system, because the galaxy is not still, it is moving. The entire galactic disk is rotating at incredible speed. Our solar system alone is orbiting the center at roughly 450,000 miles per hour. So when you try to fly straight out, you are not moving along a simple line. You are like an ant trying to run outward from the center of a spinning CD. Your path bends, twists, distorts. Not because of your ship, but because of the galaxy itself. And then there are the spiral arms. Those glowing arms you see in images of the Milky Way. They are not fixed structures. They are density waves, regions where matter gathers more densely. As your ship passes through them, you encounter stronger gravity, thicker regions of matter, like trying to run through water instead of air. This is the moment where everything must be redefined. Escaping the galaxy is not about going far, it is about breaking free. Because if you only travel outward without overcoming the gravitational binding of the system, you will never truly escape. You may drift for millions of years, leave behind the bright regions of stars, enter deeper darkness. But if your velocity never reaches escape threshold, the galaxy will simply wait. Wait for your momentum to fade, and then slowly pull you back, forcing you into orbit once again. You think you are escaping, but in reality, you are just tracing a much larger loop inside the same invisible cage. So ask yourself, what does outside really mean? Is it a place where stars disappear? Or a place where the galaxy no longer controls your fate? There is a boundary, a threshold where the pull of your old home finally gives way to the freedom of intergalactic space. But to reach it, you don't just need time. You need a rebellion against physics itself. You need to become, in a sense, invisible to the pull of billions of suns. The deeper we look, the more the Milky Way begins to resemble something alive, a system that does not easily let go, a structure that holds on to everything within it, even a tiny spacecraft carrying the ambition of a small species. And yet, there is an even more unsettling truth. Even if we were capable of beginning this journey, our starting point here in 2026 is far from ideal. We are not near an edge. We are not near an exit. We are somewhere deep inside. If the Milky Way is a vast labyrinth, where exactly are we standing within it? And is it possible that without realizing it, we have already chosen the longest path out? When you look up at the night sky from a place with very little light pollution in the United States, perhaps the deserts of Arizona or the mountains of Montana, you'll see a faint, glowing band stretching across the sky. We call it the Milky Way. From down here, it looks delicate, almost like a thin ribbon of light. But if you could rise above the atmosphere and look down at this entire island of stars from the outside, you would realize something far more unsettling about where we actually are. We are not standing on a balcony looking out into the universe. We are not at the bright center commanding everything. We are somewhere in the middle of nowhere. Numerically, our solar system sits about 26,000 light-years from the galactic center. To make that easier to imagine, if the Milky Way were a massive city like New York, we wouldn't be in Times Square. We wouldn't even be in the quiet suburbs near a highway exit. We would be inside an ordinary apartment building, deep within a distant district, surrounded by billions of other buildings. Astronomers call our region the Orion Arm, a small, relatively quiet branch located between two much larger spiral arms. And this is the trap. Because when you decide to leave the galaxy in 2026, you are immediately confronted with a harsh geographical truth. You are starting from deep inside the system. Imagine standing in the middle of a dense forest that stretches for hundreds of miles. To escape, you don't just need speed, you need direction. If you move toward the center, toward Sagittarius A star, you're heading into the densest region of stars, where radiation and gravity would tear your ship apart long before you even realized what was happening. If you try to move along the galactic plane, you would have to cross 50,000 to 70,000 light-years of stars, dust, and gravitational complexity just to reach the edge. Even if you choose the shortest path, flying straight above the galactic plane, you still need to push through about 1,000 light-years of dense material. So why call this a trap? Because from this position, every direction is a compromise. We are surrounded by what astronomers call the zone of avoidance, a dense curtain of cosmic dust and stars that obscures our view of what lies beyond. It's like being a fish swimming in the middle of the ocean. Above you is a distant surface, below you is an abyss, and in every direction there is only water. There is also a psychological layer to this trap. Because we are in a relatively quiet region, space around us appears open. But that openness is an illusion. It tricks us into underestimating the thickness of the barrier we must cross. Consider this. If we were located near the edge of the galaxy, escaping might take only a few generations. We would see the dark void of intergalactic space just beyond reach. But from where we are now, even if you traveled at the speed of light for 1,000 years, the sky around you would still be filled with stars. You would still feel surrounded, enclosed by your old home. No sense of freedom, no clear sign of escape. And this creates a profound existential pressure for anyone aboard such a journey. How do you know you are truly escaping when nothing around you seems to change, even after thousands of years? In the American West, there are highways that stretch endlessly through desert landscapes where you can drive for hours and the scenery barely shifts. Escaping the galaxy from our position is like that, but on a scale where each mile is a lifetime. Our position in 2026 is the result of billions of years of galactic motion and evolution. We did not choose to be here. We were carried here. And now, as we try to leave, we realize something unsettling. We are guests in the deepest room of a vast structure with no clear map. We are not near a window. We are not near an exit. We are deep inside the body of something immense. And to escape, we must overcome not just distance, but the quiet realization that the world we're trying to leave behind is far larger than anything we could ever perceive from this small position. So when space begins to take on shape, and we realize the path forward is not a simple straight line, what does this journey become? If you knew you were standing in the most difficult place to begin an escape, would you still move forward into the dark? Or would you accept that perhaps you were always meant to belong here, within the spiral arms of Orion? Up until now, we've been talking about the Milky Way as something abstract, a ghost made of time and gravity. But if you were truly standing on the deck of your spacecraft in 2026, ready to press the ignition, you wouldn't be flying into a number. You would need a path. Because in the universe, distance is not just an endless line, it has shape. To escape the galaxy, we must confront something called galactic geometry. This is where distances like 20,000 or 30,000 light-years stop being numbers and begin to transform into physical obstacles, structures you could, in principle, map, even detect. The Milky Way is not a uniform sphere. It resembles two plates pressed together, bulging at the center, thinning toward the edges. From our position in the Orion arm, the nearest theoretical exit is not across the galaxy, but perpendicular to it, upward or downward. Imagine you are standing inside a massive pancake. The fastest way to reach open air is not to crawl to the edge, but to punch straight through the surface. In the Milky Way, that layer is about 1,000 light-years thick. It sounds small compared to the galaxy's 100,000 light-year diameter. But remember what we've already uncovered. Even 1,000 light-years is far beyond anything our current technology can truly comprehend. And now, the journey begins to take form. If you choose this vertical route, your path becomes a straight line cutting through different layers of the galaxy. You would pass through the thin disk, a region dense with young stars and interstellar gas, and then into the thick disk, where older stars drift in quieter, more scattered patterns. But here's the problem. Leaving the disk does not mean leaving the galaxy, because the shape of this journey includes something else, the galactic halo, a vast spherical region surrounding the disk, filled with ancient star clusters and invisible dark matter. As you move upward, the stars begin to thin out. The sky ahead grows darker. But below you, the glowing disk of the Milky Way remains, stretching endlessly like a luminous creature that refuses to let go. There is another path. You could head outward along the plane toward the galactic fringe. But this route has a completely different shape. Instead of a vertical escape, it becomes a continental marathon. You would need to cross 20,000 to 30,000 light-years to reach the outer regions where star density finally fades. Why would anyone choose a path that is 20 or 30 times longer? Because in space, direction determines experience. Along the galactic plane, you might use the gravity of stars for acceleration, a kind of cosmic slingshot. But you would also face greater risks, collisions, radiation, dense regions of matter. Move vertically, and you escape density faster, but you enter isolation. Now, look at your journey map again. It is no longer a vague line in darkness. It is a climb over gravitational cliffs, or a passage through forests of stars. Distance now has structure. You begin to see calm regions and turbulent ones. We understand shaped terrain. Crossing plains is not the same as crossing mountains. In the galaxy, your terrain is the density of matter and the intensity of light. And as this journey takes on form, something changes. You no longer feel lost. You begin to see the path. You imagine your ship carving a thin line through the vast architecture of the galaxy. You begin to calculate, if we break through the thick disk, what will we see? But just at the moment you feel like you finally understand the shape of the exit, the universe reveals one final deception. A deception so profound that it makes every map meaningless. Because within the Milky Way, there is a painful truth every future explorer must face. The edge you are trying to reach does not clearly exist. You can draw a straight path outward. You can calculate every light year along the way. But what happens when you realize that the galaxy has no sharp boundary? How will you know you've escaped when the darkness ahead and the fading light behind you blend together without end? In every journey we've ever taken, we rely on boundaries. When you drive from California into Arizona, there's a sign welcoming you. When you fly from the United States to Europe, there's a clear moment when land disappears and the ocean begins. We need those markers. They tell us how far we've come and how much farther remains. But in a journey to escape the Milky Way in 2026, you are confronted with something far more unsettling. The universe has no goodbye sign. The Milky Way has no clearly defined edge. When you look at stunning astronomical images, the galaxy appears as a well-defined disk, bright spiral arms sharply outlined against darkness. But that's an illusion, shaped by instruments and perspective. In reality, the Milky Way does not end like the edge of a table. It fades, thins out, dissolves into darkness, gradually, invisibly. Imagine your spacecraft has been traveling for millions of years. You look behind you. The bright disk of the galaxy has shrunk, dimmed. You look ahead. The sky is darker than before. You might feel a surge of excitement. We've made it. We're outside. But have you? Visually, perhaps you've left the densest regions of stars. But physically, you may still be deep within its influence. Because the Milky Way is not just made of what shines. Surrounding the visible disk is something much larger, the galactic halo. A vast, spherical region filled with diffuse gas, ancient star clusters, and most importantly, dark matter. We cannot see it, but it makes up nearly 90% of the galaxy's mass. It is like an enormous invisible net wrapping around everything. So even when the stars around you fade away, even when the sky grows empty and cold, your spacecraft is still moving through a gravitational swamp created by that unseen mass. And this leads to a powerful realization. You can be outside visually and still not be free physically. The boundary of the Milky Way is not a wall. It is a transition. Like walking into a forest at dusk, you cannot point to a single tree and say, "This is exactly where the forest ends and the field begins." You only notice that the trees grow thinner, the shadows deepen, and at some point, you realize you are standing in open land. But in the universe, that transition stretches across thousands of light years. And for those aboard the ship, it becomes a form of psychological torment. They will keep asking, "Have we escaped yet?" And the answer will always be the same, maybe or maybe not. Your destination, the edge of the galaxy, becomes uncertain. And when the goal becomes uncertain, human will begins to weaken. Why continue moving forward if you can't even be sure you've crossed the line? What if you spend another 10 million years only to discover you are still inside a region that feels no different from intergalactic space? For a culture that values clear victories, clear moments of arrival, this is perhaps the most difficult truth to accept. There will be no flag to plant, no triumphant second when your ship bursts through a boundary into something new. Instead, it is a slow fading. The light behind you dims little by little until it becomes just another faint point among billions of others. Freedom does not arrive like an explosion. It arrives like a quiet realization, a long exhale that home is now too far away to ever return. Escaping the Milky Way becomes a test of acceptance. Acceptance that you may already be in open space, while invisible chains still bind you. Acceptance that, outside, is not a coordinate on a map, but a state of understanding. And when physical boundaries disappear, something else takes their place. A number, a limit, a threshold we have not yet fully faced. Because even if you cannot see the border, the Milky Way still has a very real way of reminding you that you are not yet free. That is where we encounter one of the most difficult ideas in astrophysics: escape velocity. At this point, the question is no longer how far you have traveled, but whether you are powerful enough to break the invisible tether binding you to this immense structure. If there is no boundary to cross, what defines a successful escape? Can we ever truly call ourselves free if even in the farthest darkness, the ghost of the Milky Way still shapes our path? Up to this point, we've been talking about journeys that span millions of years and distances that defy imagination. But there is a truth in physics that changes everything. You can travel as far as you want, but if you're not moving fast enough, you will never truly be free. To understand this, return to something simple, something almost every child in America has experienced: throwing a baseball straight up into the sky. What happens? It rises, slows, and then falls back down. Even if you throw it harder, like a professional pitcher, it goes higher, but the result is the same. Gravity always wins. For an object to truly leave Earth and never come back, it must reach a critical threshold: escape velocity. For Earth, that number is about 7 miles per second. Now, scale that idea up. The Milky Way, with its billions of stars and vast reservoirs of dark matter, follows the same rule. It is a deep gravitational well. And to leave it, your spacecraft doesn't just need fuel. It needs enough energy to break the invisible tether binding it to the galaxy itself. Based on the best physical models available as of 2026, scientists have estimated the escape velocity from our region of the Milky Way, about 340 miles per second, roughly 550 kilometers per second. Pause for a moment and let that number settle. 340 miles per second. Now, remember our earlier benchmark, humanity's fastest spacecraft, the Parker Solar Probe? At its peak, it reaches about 118 miles per second, a technological marvel, a symbol of human achievement. And yet, compared to what the galaxy demands, we've only reached about 1/3 of the required speed. This is the turning point, because we tend to think of escape as a matter of distance. Just go far enough and you'll be free. But physics says something very different. Escape is not about distance. It is about breaking free. So what happens if your spacecraft leaves in 2026 at current speeds? Here's the painful twist. Your ship may leave the bright regions of stars. It may travel for millions of years into the dark halo. It may go so far that Earth becomes nothing more than a fading memory. But if its speed remains below 340 miles per second, it will never truly escape. Like that baseball thrown into the sky, it will slow down, gradually, inevitably. The gravity of the galaxy weakens with distance, but it never disappears. It will follow you, patiently, silently, across millennia, until one day, after an unimaginable journey, your spacecraft comes to a stop in the depths of space. And then, slowly, inevitably, it begins to fall back. You are not an explorer escaping the galaxy. You are an object tracing a vast elliptical orbit, still bound, still owned by the Milky Way. Because in the universe, freedom is not defined by where you are, but by whether you have enough energy to say no to the pull of where you came from. Without escape velocity, distance becomes an illusion of freedom. You are like a dog tied to a leash that stretches for miles, able to run far, but never able to break away. For those who believe in the idea of personal freedom, this becomes something deeper than physics. It becomes philosophical. We often think that moving forward is enough to leave the past behind, but the galaxy teaches us something else. If you don't have the power to overcome the forces that shaped you, you remain part of them, no matter how far you go. The spacecraft of 2026 faces a barrier that cannot be broken by chemical engines or ion propulsion alone. We are missing something fundamental, a leap in energy, a force strong enough to transform us from a satellite into an outsider. And here is the most unsettling thought of all. What happens if a generation aboard that ship realizes they have traveled so far they can no longer see their home galaxy, yet their instruments still show they are being pulled back? They would exist in a void, isolated, drifting, but not free, trapped in a liminal space where home has vanished, yet the wider universe still refuses to accept them. What happens if we go far enough, but never fast enough? Do we condemn ourselves to an eternal wandering, unable to arrive and unable to return? There is a dangerous illusion in the universe, one that waits for you at the very moment you believe you've won. It is the illusion of freedom, based on what you can see. Here on Earth, when you travel far enough from a city, the lights fade, the noise disappears, and you feel free. But in space, distance is a master deceiver. Look at how our own system behaves right here in the solar system. Think about comets. They are some of the loneliest travelers we know. Some of them journey so far from the sun that they pass beyond the orbit of Neptune into the dark outskirts of the Oort cloud, a distant region where the sun becomes nothing more than a faint point of light, no brighter than any other star in the sky. At that distance, if you were standing on a comet's surface, you would feel completely free. Endless darkness surrounds you. Home feels like a distant memory. But that is the trap. Because no matter how far it travels, that comet is still held within the gravitational grasp of the sun. It is not escaping into infinity. At the farthest point of its journey, an invisible tether tightens, and the comet is pulled back, beginning a loop that may last thousands of years. It thinks it is escaping. In reality, it is drawing a very large circle. Now apply that same brutal logic to your spacecraft as it attempts to leave the Milky Way. Imagine you've been traveling for 10 million years. You look out the window. The bright nebulae are gone. The dense star fields have faded. Space around you now feels terrifyingly empty. Behind you, the massive disk of the galaxy has shrunk into something almost beautiful, like a painting suspended in darkness. And in that moment, a powerful sense of freedom takes hold. You believe you've made it. You believe the emptiness ahead is your passport to true independence. But physics tells a different story. You must confront a difficult truth. Escaping what you see is not the same as escaping what holds you. Starlight fades with distance, following the inverse square law. But gravity does not simply disappear. The combined pull of hundreds of billions of stars and vast amounts of unseen mass continues to extend outward. This is the gravitational field, an invisible structure with no gaps, no edges. So even if your spacecraft is tens of thousands of light years away from the galactic disk, it is still being pulled, still part of the system, still bound. If your speed remains below the escape threshold we discussed earlier, then the emptiness you see is not freedom. It is a waiting zone. This is the trap of distance. It gives you the feeling of progress, while in reality, you are only stretching the leash. To the human mind, emptiness often feels like liberation. But in astrophysics, emptiness can be the most complete form of confinement. You may see the entire galaxy behind you, small, distant, beautiful, and yet realize you are still under its control. You are like an astronaut on a spacewalk, connected by a tether that stretches infinitely. You can drift far away from the ship, but you will never become independent. This realization strikes directly at the ambition of 2026. It tells us that every map we draw, every milestone we aim for, may be illusions if we cannot overcome the invisible force holding us back. Now imagine the 100th generation aboard that spacecraft. They were born in darkness, raised to believe they are citizens of free intergalactic space. Until one day, their most precise instruments reveal the truth. Their velocity is slowly decreasing, approaching zero. And then, on their radar, the galaxy behind them begins to grow once again. This is not a journey into the future. It is a forced return. The trap of distance teaches us something profound. In the universe, vision can lie. To be truly free, it is not enough to see emptiness. You must have the power to tear through the gravitational field that surrounds you. You may look back and see the entire galaxy resting in your palm, and feel for a moment that you've conquered fate. But what happens when you realize that that tiny disk of light is still the one steering your ship from trillions of miles away? At this point, we have to face a naked truth. We've talked about the need to reach 340 miles per second to escape the Milky Way. We've seen the trap of distance and the persistent pull of gravity. But now, a far more practical question stands before us in 2026. How do we actually reach that speed? The short answer is simple. With current technology, we simply cannot. Look at the best athletes humanity has ever built. Voyager 1, the legendary probe that has left the solar system, is traveling at about 11 miles per second, 17 kilometers per second. New Horizons, which sent back stunning images of Pluto, reaches around 9 miles per second, 14 kilometers per second. And at the very peak, there's the Parker Solar Probe, clocking in at about 118 miles per second, 190 kilometers per second. Looking at these numbers, you might think, we're making progress. From 11 to 118, just a few more breakthroughs and we'll hit 340. But this is where the technology gap truly reveals itself. Because it's not just a gap in numbers, it's a gap in the nature of speed itself. There's a quiet secret in aerospace engineering that most people never notice. Our highest speeds don't come from the spacecraft's own engines. They come from something called gravity assist, a cosmic slingshot. Imagine your spacecraft as a surfer trying to gain speed by catching the wake of a passing truck. The Parker Solar Probe didn't reach its record speed because it has an incredibly powerful engine. It reached that speed because it fell deep into the sun's gravitational well. It is quite literally falling toward the sun at extreme velocity. But here's the fatal limitation. That speed is not a stable cruise speed. The moment the spacecraft moves away from the sun or major planets, the very gravity that accelerated it begins to slow it down. The speed is temporary, like sprinting uphill after a running start. Once the push is gone, momentum fades. The reality is stark. No spacecraft today can maintain a stable, sustained speed high enough to escape the galaxy. Our chemical rockets, the same technology that took us to the moon, have already reached their physical limits. They're like sprinters, explosive, powerful, but only for a short burst. To escape the Milky Way, we need something entirely different, a marathon runner that can move at lightning speed for millions of years. We lack engines that can provide continuous thrust without carrying enormous amounts of fuel. We lack materials that can endure the wear of space over immense timescales. And most importantly, we lack a way to generate energy from the vacuum itself. In 2026, we can build extraordinary things, advanced AI, microscopic chips. But in terms of space propulsion, we are still in something like a Stone Age. We are trying to cross an ocean on wooden rafts, when what we truly need is a nuclear-powered carrier. This gap creates a massive void in our entire plan. If we left today, our spacecraft would be like a car running out of fuel just after leaving the garage. We may have a perfect route, a clear understanding of galactic structure. But without a heart powerful enough to keep beating across millennia, it's all just theory on paper. The technology gap is not simply that we are 3 times too slow. It's that we are using the wrong kind of tools for a challenge of this scale. We are trying to use thrust to defeat destiny. But humanity has never stopped at the sight of a wall. When one technology reaches its limit, that's when the most radical ideas begin to emerge. To escape this vast cosmic cage, we cannot simply improve what we already have. We need a revolution in how we define motion itself. So if we want to go faster, what must we change? Is there a form of energy hidden within the fabric of space itself? Or must we abandon mechanical engines entirely and search for something fundamentally different? If the chemical engines of 2026 are nothing more than rafts on an ocean, then the next question becomes, what kind of ship do we actually need to cross it? To break free from the chains of the Milky Way, humanity must move beyond burning chemical bonds and begin to harness the power of the nucleus, of light, and perhaps even of the vacuum itself. Welcome to the era of future propulsion. This is no longer science fiction. These are concepts already being explored by engineers at NASA, SpaceX, and leading physics institutes around the world. The first step is nuclear propulsion, from nuclear thermal engines to the far more powerful promise of fusion. Instead of fire, we use the same force that powers the stars. A fusion engine could provide continuous thrust, allowing a spacecraft to accelerate steadily without the need for massive fuel tanks. But if we want to go even further, we begin to explore something more radical. Laser sails. Ultralight spacecraft pushed forward by the pressure of light itself, driven by powerful laser arrays stationed on Earth. And at the very edge of human ambition, there is antimatter propulsion. Just a few grams of antimatter could release more energy than any fuel humanity has ever used, by orders of magnitude. These technologies don't just make us a little faster, they redefine the game entirely. Because for the first time, they push us toward meaningful fractions of the speed of light. Let's look at what that means. At 1% of light speed, about 1,860 miles per second, 3,000 kilometers per second, we would already be moving 15 times faster than the Parker Solar Probe. At that speed, escaping the galaxy begins to feel possible. And at 10% of light speed, a target explored by projects like Breakthrough Starshot, we would be traveling at 18,600 miles per second. At that velocity, a trip from Earth to the Moon would take less than 13 seconds. But this is where the mathematics delivers its most brutal twist. Even at those unimaginable speeds, reality barely changes. At 1% of light speed, escaping the galaxy would still take millions of years. At 10%, a speed we don't yet know how to sustain, especially for a crewed mission, the journey would still require hundreds of thousands of years. Do you see the problem? Even if we build machines worthy of gods, even if we solve energy, even if we achieve escape velocity, the Milky Way remains too vast for the lifespan of a human being. We've shortened the timeline from eternity to hundreds of thousands of years. But for a species that lives 80 or 100 years, those two numbers are effectively the same. They both mean you will never arrive. This is why the promise of future technology is only a conditional hope. It allows the ship to reach the destination, but not the people aboard it. Speed does not erase the problem. It only reveals it more clearly. We are trying to use a finite life to conquer an infinite scale. For a culture built on the belief that every limit can be overcome, this becomes a lesson in humility. We may conquer physics, but we have not yet conquered biology. We may build antimatter engines, but we do not know how to preserve the human body and mind across countless generations. And this is the moment when excitement begins to shift into something else. Because speed doesn't just shorten time, it introduces new dangers, ones we never had to consider at lower velocities. High speed is not a free pass. It comes with a cost that no material on Earth may be able to withstand. Because when you move at 10% of the speed of light, space is no longer a silent vacuum. It becomes a deadly minefield, where even a grain of dust carries the energy of a nuclear explosion. So we have to ask, are we chasing speed, or are we walking directly toward destruction? In the previous section, we imagined spacecraft reaching 10% of the speed of light, cutting down journeys that would otherwise take millions of years. We began to see speed as a savior. But in cosmic mechanics, speed is a brutal double-edged sword. Because when you move fast enough, the very nature of space around you changes. What you once believed to be empty vacuum suddenly becomes a battlefield filled with invisible mines. The first and most devastating problem: dust. Interstellar space is filled with microscopic particles, tiny grains of matter so small you could never see them with the naked eye. At low speeds, they are harmless. But at 10% of light speed, about 18,600 miles per second, their kinetic energy becomes catastrophic. At that velocity, a grain of sand striking your spacecraft would release energy comparable to a powerful explosive. A cloud of dust, the kind you might casually observe in astronomical images, would become a barrage of high-speed projectiles, a continuous stream of impacts. To survive, your spacecraft wouldn't just need a powerful engine, it would need armor meters thick, or energy shielding systems we don't yet know how to build. And even then, at those speeds, that armor would erode over time. You are not just traveling, you are racing against the gradual destruction of your own ship. But dust isn't the only threat. There is also radiation. On Earth, we are protected by a powerful magnetic field and a dense atmosphere. They shield us from cosmic rays and high-energy particles from the sun. But once you leave the protective environment of the Milky Way, you enter exposed interstellar space. Here, high-energy radiation can pass through your spacecraft as if it were paper. And it gets worse. At relativistic speeds, your spacecraft begins to collide with space itself. Photons and protons, normally harmless, become lethal. Due to the Doppler effect, background radiation shifts into X-rays and gamma rays. Your ship is no longer a shelter. It becomes something closer to a microwave chamber, where astronauts are bombarded from every direction by particles powerful enough to damage DNA in seconds. The ship itself must endure an enormous energy load. Every electronic system, every life support function, must operate in an environment of extreme radiation and electromagnetic stress. At those speeds, even the smallest error becomes fatal. A navigation mistake of just a fraction of a degree, and your ship could collide with a tiny object and vaporize instantly. This is the twist for anyone who worships speed. Going faster doesn't make the journey easier, it simply changes the kind of danger. At the slow speeds of Voyager 1, the threat is time decay, isolation, eventual failure. At the high speeds of the future, the threat becomes instant destruction. We try to solve a problem of time, only to create a far greater problem of survival. For a culture that values safety and efficiency, this forces an uncomfortable truth. Technology, whether in 2026 or even 2126, may give us speed, but it does not yet protect us from the consequences of that speed. We are building the fastest arrows in history, but we remain fragile biological beings riding on their tips. The speed of light is not a shortcut to freedom. It is a region of extreme risk where space itself becomes an active enemy. And this leads to a final realization. If a spacecraft cannot simply be a mechanical machine, steel hull, engines, fuel, then it must become something more. A self-sustaining ecosystem, a fortress, perhaps even a miniature world. So if a spacecraft cannot just be a machine, what must it become? To survive millions of light years, to cross fields of dust and radiation, do we need a vessel that doesn't just travel, but one that can truly live? When we realize that speed cannot carry us to the destination within a human lifetime, and that space itself has become a deadly minefield, our definition of a vehicle begins to collapse. To escape the Milky Way in 2026, we cannot rely on a ship in the traditional sense. We don't need a machine to move us. We need a self-sustaining ecosystem. Let go of the image of cramped cockpits and rows of seated astronauts. The vessel capable of surviving a million-year journey must be something far more radical, what scientists call a world ship. And the first challenge is not propulsion, it is life support. Here on Earth, we take air, water, and food for granted. But in the void of space, every atom of oxygen you breathe, every drop of water you drink, becomes priceless. No ship can carry enough supplies for 1,000,000 years. It must become a perfect closed system. Everything must be recycled. Everything. The water you waste today must become the water you drink tomorrow. The carbon dioxide you exhale must be absorbed by artificial forests within the ship, converted back into oxygen and food. This is not a laboratory, it is a living cycle, a miniature Earth enclosed within a shell of advanced materials. The ship must contain soil, plants, microbes, a complete biological loop that cannot fail, even for a moment. But any living system inevitably breaks down, and that leads to the next challenge, self-repair. On a journey across the galaxy, there are no repair stations, no rescue missions, no turning back for spare parts. If the hull erodes after 500,000 years from constant exposure to cosmic dust, the ship must be able to rebuild itself. It must function like a living organism, capable of healing its own wounds. Its AI systems must predict failures before they happen, managing entire swarms of nanorobots tasked with maintaining structure, systems, and life itself across millennia. And here, a deeper realization begins to form. This is no longer a vehicle. A vehicle takes you from point A to point B. But on a journey longer than the entire history of humanity, the ship itself becomes point B. It becomes the only home, the only reality. It is not a metal container carrying you out of the galaxy. It is a living island drifting through an endless black ocean. For a culture that values mobility and control, this is a profound shift. On a world ship, you don't drive the vessel, you live inside it. You are no longer a passenger. You are part of the system, a component within a vast biological machine. And this changes everything. The goal is no longer to arrive quickly. The goal is to endure. The ship no longer serves humanity. Humanity and the ship become a single, interdependent system, a symbiosis. And once the line between machine and life dissolves, once the ship becomes a self-contained world, capable of protecting itself from the dangers of speed, we encounter a problem far more complex than engineering. If the ship is a world, then who are the people inside it? Will they still be the same humans who left in 2026, with the same dreams, the same desires? Or will they become something entirely different, shaped by time, by isolation, by the environment of this artificial world? And if it is a world, then who will live there? Will the children born in the 10,000th year of the journey still care about escaping the Milky Way, when their entire universe exists within the walls of that ship? Once the ship becomes a world, another harsh reality begins to emerge, one that no technology in 2026 can solve. The limit is biology. Because the journey spans tens of thousands of years, we are forced to accept a concept known as the generation ship. And this is where the deepest psychological blow lands. The people who leave will never be the ones who arrive. Imagine the first Americans stepping aboard. They carry pride, ambition, memories of California sunsets, and snow-covered winters in New York. They know where they are going. They know why they are going. But 500 years later, the 20th generation is born. To them, Earth is no longer home. It is an abstract idea, a distant world preserved in digital archives, never seen, never touched. Their home is something else entirely. Metal corridors, artificial gardens, the endless hum of engines. At this point, something profound happens, an identity shift. The original mission, escape the Milky Way, may no longer feel meaningful. To later generations, it may become a burden or even an empty belief system, a kind of inherited mythology. They are born into a mission they never chose. They are, in a sense, prisoners of a dream belonging to ancestors long gone. The journey is no longer a scientific project. It becomes history. The ship no longer carries people. It carries an entire civilization, one that is evolving in total isolation. Language will change. Values will adapt. Morality itself may be reshaped to fit survival within confined space. Children born in the 10,000th year may look at images of the Milky Way, its glowing arms stretching across space, and wonder, why did our ancestors ever want to leave something so beautiful? Because for them, that galaxy is not home. It is something distant, abstract, while their reality is defined by the darkness outside the hull. In a way, we are creating a new kind of human, star children, beings whose minds and bodies are shaped not by the rhythms of a planet, but by the endless continuity of a journey. But the greatest fear is not that they will forget Earth. The greatest fear is something else. While humanity evolves psychologically, time itself is quietly reshaping their physical reality. Because time doesn't just change people, it changes everything. And this leads us to a deeper question. If a human being lives for thousands of years within an artificial world, will they still be human enough to face what awaits them beyond the galaxy? When we talk about a journey that lasts tens of thousands of years, we often think only about mechanical failure. But there is something far more fragile than steel or polymer: human culture. Here on Earth, consider the difference between us today and our ancestors in the Middle Ages. In just 1,000 years, language, belief systems, and moral values have changed so dramatically that we would struggle to fully understand one another. Now multiply that by 10, by 20, and place it inside the complete isolation of a world ship. The greatest challenge is not keeping the engines running. It is keeping belief from collapsing. The values we hold in 2026, individual freedom, consumerism, dreams of wealth, and personal success, would become meaningless inside a closed system where every resource must be shared and tightly controlled for survival. A new moral framework would emerge: survival ethics. In this system, a person's value is measured by how much they contribute to the stability of the ship's ecosystem. Language, too, would not remain unchanged. After thousands of years, the English we speak today would evolve into something entirely different: a hybrid dialect shaped by technical terminology, confined living, and new concepts born from life in space. To the people of the 10,000th year, records from 2026 might feel like an ancient, almost sacred language, the voice of distant ancestors or perhaps forgotten gods. But the most unsettling transformation is something else: mission drift. Be honest for a moment. Would a child born in the 500th generation, inside a world where the only horizon is a metal wall, truly care about escaping the Milky Way? The original mission may fade. It may become myth or legend, or even be seen as the madness of long-dead ancestors. Future generations might choose to stop accelerating, or simply live their lives within the warm, contained cocoon of the ship, rather than venture into the unknown darkness beyond. At that point, everything changes. The ship is no longer carrying humans on a mission. It is carrying a civilization that is evolving on its own. The Milky Way is no longer an obstacle to overcome. It becomes a distant backdrop, irrelevant to the daily life of a new society. A society with no nations, no sky, no true concept of Earth as home. We begin this journey as explorers, but we may end it as something entirely different. We are sending a seed of humanity into space, but we cannot control what it will become. What kind of civilization will grow after 10,000 years of radiation, isolation, and time? And there is one more layer to this realization. While they are changing, the galaxy itself is not standing still. We imagine the Milky Way as something static, a fixed structure we are trying to escape. But it is evolving, aging, transforming every second. So even if we reach what we believe to be the exit, will that exit still exist? If everything is changing, us, the ship, and the galaxy itself, what does it even mean to arrive? Throughout this journey, we've unconsciously treated the Milky Way like a rigid stone labyrinth, something fixed in place, waiting for us to find a way out. But the truth is very different. The Milky Way is not a maze, it is a storm. When you attempt to leave it in 2026, you are not escaping a stationary object. You are trying to break free from something that is rotating, racing through space, and constantly reshaping itself at extraordinary speeds. Start with our own home. The solar system is not standing still. We are moving along a vast orbit around the galactic center at roughly 450,000 miles per hour. One full revolution, a galactic year, takes about 225 to 250 million years. The moment your spacecraft departs, it becomes part of this motion. But here's the critical detail. The stars around you are moving too. Each one follows its own path. Within just a few thousand years, the familiar constellations, Orion, Ursa Major, will completely dissolve. Your star map becomes outdated faster than any piece of software ever could. You cannot rely on the stars for navigation, because your landmarks are moving with you or against you. And the motion doesn't stop there. The galaxy itself is evolving. Over the millions of years of your journey, entire regions of space will change. New stars will be born from clouds of gas, bright, hot, and unstable. Old stars will die, exploding as supernova events that release unimaginable energy. Imagine traveling through a region you once believed was safe, based on data from 2026, only to discover that a nearby star has exploded, flooding your path with lethal radiation your ancestors could never have predicted. And this leads to a profound logical twist. Your starting point and your destination are never the same. The Milky Way you leave behind in 2026 will not be the Milky Way you look back at a million years later. Spiral arms shift, dust distributions change, gravitational balances evolve. You are not escaping a place. You are escaping a moment in time. This journey becomes something stranger, a pursuit of a moving target. You are trying to exit a system that is itself moving and transforming, which turns navigation into a mathematical nightmare, because you must calculate not where the exit is now, but where it will be millions of years into the future. For a mindset that values precision and long-term planning, this becomes a humbling realization. We want to conquer the universe with fixed numbers, but the universe responds with constant change. And at some point, after traveling far enough, you will look back and realize something deeper. You are not just leaving a planet, you are leaving a flow, a vast current of matter and motion that you were once part of. And when all your reference points have changed, when old stars have died and new ones have been born, what does it actually feel like to be outside? Is it a triumphant moment of freedom? Or is it a profound loneliness when you realize that the only thing that does not change is the emptiness ahead? So what does it truly feel like to leave? When the last light of your home galaxy fades and you finally sever the invisible tether, is that the moment you find yourself, or the moment you realize you've lost everything? We have spent millions of years aboard this ship waiting for a single moment. A moment we imagined would feel like crossing a threshold, a door, a finish line, a radiant boundary where we could finally declare to the universe, we are free. But the reality of leaving the Milky Way will never unfold that way. There will be no fireworks, no sudden shift in light. Escaping a galaxy is an experience of gradual fading. Imagine you are part of the 5,000th generation born aboard this world ship. You stand in the largest observation chamber. For thousands of years, your sky has always been filled with stars, even as they slowly grew more distant with each passing millennium. You don't realize you've left by looking outside. There is no sign that says you are now beyond the galaxy. Instead, you begin to notice something subtle. The spaces between stars are growing wider. The darkness becomes deeper, denser than anything your ancestors ever saw in places like Arizona or Montana. The brightest stars fade into faint points of light, and the Milky Way, your home, your cage, your origin, has collapsed into a distant, glowing disk behind you. The most beautiful and most brutal truth is this: you do not leave in a moment. You leave in a process so slow, you cannot feel it. It is like aging. You don't wake up one morning suddenly old. You only realize it when you look back at who you used to be. Leaving the galaxy is the same. You only know you've escaped when you understand something irreversible. Even if you turned around and traveled for another 1,000,000 years, you would never reach those stars again. Gravity has released you. The tether is gone. But it happened so quietly. There was no sound. And in that silence, a feeling unlike anything in human history begins to take hold. You are now in the intergalactic void. Ahead of you, emptiness. Behind you, the past. You no longer belong to any system. You are no longer from Earth, no longer of the Milky Way. You are something else. A singular existence, drifting between islands of light. For a spirit that values independence, this is the ultimate freedom. But it is also a terrifying one. You have severed the cord that once connected you to your origin and become, in a sense, an orphan of the universe. Every equation, every technological breakthrough from 2026 has only been preparing you for this quiet moment. The moment when all the noise of the galaxy fades and you realize freedom is not a place filled with light. It is a vast emptiness, one that you must fill with your own meaning. Until you look back and you see that glowing disk, so small you could cover it with a single finger. And in that moment, one final question, the most important question of the entire journey, begins to form in your mind. After millions of years moving through darkness, after surviving fields of dust and the invisible chains of gravity, that moment finally arrives. You walk to the observation window of your world ship and look back. The Milky Way is no longer a faint band of light across the night sky, like your ancestors once saw from the American countryside in 2026. It has become something else entirely, an object. For the first time in the history of life, you see the full structure of your former home from the outside. You see the luminous spiral disk, its arms curling gracefully through space. You see the bright galactic center, glowing like a beating heart. And surrounding it all, vast clouds of dark dust, like a silent cloak. But that beauty comes with something deeper, an emotional shift. You realize that everything humanity has ever known, every war, every empire, every love story, and even the tiny planet we once called Earth, all of it exists as nothing more than microscopic fragments within that glowing disk. What once felt like an entire universe is now just a point of light. When you were inside it, the galaxy was a maze, an overwhelming force that shaped your fate. But from the outside, it feels fragile, a lone island of light floating in an endless black ocean. You realize something undeniable. You have truly left the system. You are no longer bound by it. But you are no longer protected by it either. The freedom you pursued for millions of years now reveals itself as complete separation. You are looking at your own past. The light from that distant disk has taken tens of thousands of years to reach your ship. You are not just seeing a galaxy, you are seeing a ghost of your origin. To those aboard, the Milky Way becomes like an old photograph, found in a forgotten box. It evokes memories of a place they've never known, yet one that gave them existence. Its smallness makes every ambition from 2026 feel distant, almost unreal. But just as you begin to drift into that quiet reflection, something else happens. You turn around, and you realize in this universe, freedom does not mean stillness. Because ahead of you, there is not just emptiness. As your eyes adjust to the true darkness of intergalactic space, you begin to see something else. This journey was never an ending. It was only the beginning of something far greater. When our ship finally severs the last threads of gravity and the Milky Way fades into a distant island of light behind us, we tend to imagine a moment of absolute freedom. But the universe has its own way of reminding us how small we are. Because the moment you believe you've escaped the maze, you realize you've stepped into something far greater. Welcome to intergalactic space. What lies ahead is not just emptiness. It is an abyss. If the distances between stars once overwhelmed you, then the distances between galaxies will leave you speechless. Your next potential destination, our nearest large neighbor Andromeda Galaxy, is about 2.5 million light-years away. Remember what it took just to leave home. Millions of years to cross tens of thousands of light-years. And now, the void ahead is 100 times larger than the journey you've already endured. Even with the fastest technologies we can imagine, reaching Andromeda would require a timescale longer than the entire existence of humanity on Earth. But the universe is not just a collection of isolated islands. From a greater distance, a new structure begins to emerge, the cosmic web. In this vast network, galaxies do not drift randomly. They are nodes connected by enormous filaments of dark matter and gas. What we just escaped, the Milky Way, is nothing more than a single node in a structure that stretches across billions of light-years. And this leads to a deeper realization. You didn't escape a system to become free. You simply left one cell and entered a much larger organism. What felt like an escape was actually a transition, from a smaller cage to one millions of times larger. The Milky Way's gravity may no longer bind you, but now you exist within something else, the local group, and beyond that, the Laniakea supercluster. You were never outside the system. You are only beginning to understand it at a scale that humans in 2026 could barely even describe. Leaving the Milky Way was never the final step. It was the first movement of a child stepping outside their home, only to discover an entire city, a continent, a universe waiting beyond. So why do we accept such a cost? Why sacrifice generations, identity, connection, for a journey into something even more vast and perhaps even more empty? Why do we long to see that glowing disk from the outside instead of remaining within its warmth? Why do we feel this pull to go beyond? Why are we obsessed with leaving when every escape only reveals a universe that is always larger than anything we could ever conquer? After traveling across millions of light-years, after confronting the brutality of physics and the fragility of biology, a question inevitably rises. Why do we do this? Why would we leave behind Earth, green, alive, familiar, and abandon the warm structure of the Milky Way for a journey whose ending we will never personally see? If the destination only leads to a larger cage, is this escape meaningless? To answer that, we have to look deeper into the code that has shaped humanity for millions of years. The first force is survival. History has taught us one truth: nothing lasts forever. Even the sun will one day fade, and the Milky Way itself will eventually collide with the Andromeda Galaxy. Leaving is not betrayal, it is preservation. We don't escape because we reject our home. We escape because we refuse to let our story end on the final page of a book called Milky Way. But survival is only part of it. What truly drives us forward is something stronger: curiosity, a force deeper than fear. We are a species that cannot tolerate a boundary without wondering what lies beyond it. From pioneers moving west across America to astronauts stepping onto the moon, Humanity has always been drawn to the idea of the frontier. And once we know there is a way out of the galaxy, we will never be at peace until we try to reach it. And then, there is something even more enduring: legacy. We do this not for ourselves, but for those who will come after us. We become the launch pad. We sacrifice the ordinary span of our lives so that future generations, born thousands of years into the journey, can witness something no human has ever seen: their entire home from the outside. And here is the final realization: we don't actually need to arrive for the journey to matter. The meaning of leaving the galaxy is not found in the final coordinates where the ship stops. It is found in the act of trying, in the fact that a carbon-based species born on a small planet can understand the laws of something billions of times larger than itself. The fact that we are here, right now, in 2026, even asking how to leave the galaxy, is already a kind of escape. We don't need to reach it, but we need to understand it. That desire to know, to question, to go beyond, is what transforms us from ordinary beings into participants in the universe itself. We try because we are the species that always asks, why? And in the vast darkness of intergalactic space, the answer may not lie among distant stars, but within the flame of will we carry from Earth. So after everything we've explored, after every barrier that seemed impossible, would you step aboard that ship? When the final lights of Earth fade and the greatest journey begins, what would be the last thing you carry with you in your mind? Our journey, from those first steps on a launch pad in 2026 to the moment we look back at the Milky Way from the depths of intergalactic space, was never truly an escape. It was a long, quiet embrace, lasting millions of years between humanity and the universe. Now, let your mind begin to soften. Imagine yourself lying in the observation chamber of the world ship. Around you, there are no numbers anymore, no calculations, no pressure to reach escape velocity, no fear of cosmic dust. All of that has drifted into the past. There is only you and the vast, silent darkness, the quietest space a living being can ever feel. Behind you, the Milky Way has become a gentle glow, like a small night lamp at the far end of a corridor called time. It no longer pulls at you. It no longer roars. It simply rests there, radiating a soft warmth, reminding you that once you had a place called home. Now, look forward. Intergalactic space is not frightening. Not anymore. It feels like a velvet blanket, deep black, smooth, endless. Distant galaxies shimmer like diamonds scattered across a calm, silent ocean at night. You no longer feel like you are traveling. You are drifting, weightless, directionless, at peace. All the urgency to arrive has dissolved, because here, on this ship, within this journey, the present moment is the destination. You are the breath of thousands of generations before you, and the dream of thousands more to come. You are a single heartbeat in an infinite void. Now, breathe in slowly and exhale. Feel the vastness of the universe holding you. You are small, yet you carry an entire civilization within you. You are alone, yet connected to every atom born at the beginning of time. In this stillness, there is no engine noise, no echoes of the old world, only your breath, blending into the silent music of space itself. The journey beyond the galaxy has led you to the purest state of existence: peace. A peace no planet can give. A peace that can only be found when everything has been released, and you have allowed yourself to dissolve into the eternal dark. The light of your old home is fading, slowly, gently, and the darkness ahead welcomes you like a soft embrace. It is time to leave the questions behind. It is time for your mind to rest. The Milky Way is asleep now, And so are you. Sleep well among the stars.